Hey guys, Rudi here with another CSSE1001 and 7030 Python tutorial. Now this week we're going to be looking at the week 11 tutorial, which is on recursion. It's one of my favorite topics in the course, definitely, because it's really trippy and it's really hard to wrap your head around, but once you do, you can do some really powerful stuff with it. Okay? So let's just dive right into it. What's recursion? We've got a bit of a box here, a bit of hints and stuff, but let's sort of just talk about it. Recursion is, it's a recursive function is basically when we have a function that calls itself. Okay, so what do I mean by that? Well, let's just copy paste out this add function into here and have a bit of a look at it. So this is supposed to add up all the elements in a list, right? So basically do what sum does, more or less. Except we're going to implement this recursively. So let's see. Basically, we've got this listy, this add here, and we're adding up our list, and we can see that down here we're actually calling add in the return. Okay, now add is the function we made here. So the function's sort of going to loop recursively in and of itself as we go through, right? So we're continuously calling add and add and add and add as we sort of work our way into the list. Now you got to be careful here, right? Because what's to stop this function from just going forever, right? And that's what this if statement's about. So generally when we have recursion, right, because we don't want to just loop over the same function call forever and ever and ever, we need to have a base case, right? A sort of a place where we know to stop recurring because we've hit the end, right? We've sort of looped over ourselves enough times that we've finished adding up all the elements in this list and we know we need to stop. And so generally your recursive case works to sort of try and reduce the sample size of the problem as you go, and then your base case is kind of the end of that. So what do I mean by that? Well, let's see here. Add listy, what are we doing here? If our list is empty, we've hit our base case, so return 0, right? This makes sense. Like if we've got an empty list, what's the sum of all the elements in it? It's nothing. But in the recursive case, right, we're going, cool, grab the first guy and call add again on listy from 1 onwards. So basically everything except the very first element. So we can see that even though we've called add again, we've actually called it with a slightly smaller list, right? We've taken out one element. So if we keep sort of repeating this procedure, excuse me, we're going to eventually arrive at a point where our list is empty, right? Because we keep just taking one thing out of it and out of it, and that's when we're going to hit this return, and that's where our recursion will stop. Okay, so just to sort of prove this is working, let's just boot up a shell, add some numbers. Okay, and we get 15. So we can see it's working. But let's sort of try and break down exactly what's happening here. So let's see, when we make the first call, I'm sort of just going to type this out here. We make the first call. This is what I put into the shell, right? Now let's think about what this statement here is going to return. Okay, well, we're going to go here. Is our listy empty? No. So we're going to return this. Listy of 0 plus add of this. Okay, so we're going to return, well, what's listy of 0? Listy of 0 in this case is the first thing in the list, so that's going to be 1. Plus, and then we're going to call add listy again, right? But we're not going to call it with the whole list. We're going to call it with the 1th element and onwards. So now we've called it with this. Okay, then Python goes, oh, okay, cool. So now I need to evaluate this. What's this? So 1 plus, okay, so what does add return? Well, it returns the first thing in the list, 2, added 2, calling add on the rest of the function. So same thing again, add 3, 4, 5, right? Because we're going to strip out the first thing in our list. Now remember this time we've called listy. Our listy in this call is 2, 3, 4, 5, right? So when we strip out the first thing, we're actually stripping out a 2, okay? Plus add 3, 4, 5. Okay, now again, what does this add give us? We're still not empty, so we get 3 plus, strip out the first thing, 4 and 5. Okay, you can just keep looping through this. Oops, a doodle. See, recursion gets really repetitive if you try and stack it out, but we're almost there, right? 4 plus add 5, okay? At this point here, we're still going to strip out the first thing, which happens to be a 5. And then when we try and call listy from the 1th element onwards, well, we don't have a 1th element and onwards, right? So we're just going to chuck in an empty list. Now, the final call we get here, 1 plus 2 plus 3 plus 4 plus 5 plus. Now, what does add this give us? We're going to go into this case here now, right? Because we've hit our list is empty, and we return a 0. And then Python rewinds or unwinds back up the recursion and goes, oh, cool, now I've just got all these pluses here. And we can see that this is actually the sum of all the elements in our list. Okay, so pretty nifty. Don't feel too bad if you sort of can't wrap your head around this concept straight away compared to all the other concepts in the course. This one is by far the most, it's got the biggest sort of learning curve, right? You just have to look at enough of these functions, sort of try and implement enough of them yourself until you sort of hit that click moment. Okay, but that's also what this tutorial solution's for about, right? We're going to try and look at some sort of useful cases where we can figure out what's happening with recursion and do some debugging and try and implement some ourselves, okay? But that's essentially what's happening here. We're sort of just unpacking this list sort of and trying to reduce our sample space every time, right? So notice every time we called add, we were reducing down until we could confirm that we hit our base case. And at that point, we're essentially done. Okay, so let's look at the actual questions here. What's question 1? Minimum. It's getting a drink. Okay. Write a recursive function which takes a list of numbers and returns the smallest element in the list. If the list is empty, raise a value error. Okay, so def minimum. It's going to take a listy. Okay, so let's have a look at this. We've got this, if the list is empty, raise a value error. So that's actually pretty straightforward, and that doesn't really have anything to do with recursion. So if our list is empty, i.e. 0 length, or I guess you could have also done this statement as well, it's the same thing. Raise, what was it, value error? Yeah, value error. And if you didn't know, you can put error messages here inside your exceptions. So list is empty. Okay? Now, that doesn't really have anything to do with the recursive part of this. So we're actually going to we're just going to move past that and try and get to the actual recursion stuff here. So with recursion, you got 2 really important things you need to think about. One is the base case, right? What is the base case we're going to try and think of for our minimum function that we can try and reduce our list down to, right? And then the other thing you've got to think of is, how would I do a singular step of that recursive algorithm? Now, for anyone who's familiar, who's done some maths, recursion is very strongly intertwined with the concept of mathematical induction, right? And for those who aren't familiar with induction, basically the gist of it is, assuming we have a base case that works, right? So that's what we do with recursion, right? We set one base case that works. For instance, here we said, well, if the list is empty, I know that the sum of things inside that is 0, right? Okay. The second step of recursion is basically to assume your function already works. Now that's going to sound a bit weird, but if we look back up at what's happened here, we can basically say, well, let's assume that this add function adds up all the things in a list, okay? At that point, we've got this base case and we assume it works. So if we can sort of figure out how we would do a single iteration of our recursion, we can actually solve it, right? Because if we start at the base case, or if we prove that we can keep recurring down towards our base case, we know the base case works, right? Because we set it to work. And at that point, we've actually sort of proved that our algorithm will work. That sounded really, really trippy and probably confused a lot of you. But if you're not too familiar with induction, don't worry about it too much. Just sort of note that we can kind of assume our function works when we're trying to create it. So let's have a look at what's happened in this add, for instance. We went in our recursive case, right? So we set up our base case, we know it works, that's all good. If we look at our recursive case, we're basically saying, well, let's take out the first element of the list and add it to the sum of the rest of the list, right? At this point here, we basically gone, cool. Assume that the add function gives me the sum of everything in here, okay? Because at that point, we're basically going, oh, cool, I'm going to add up the first thing and I'm going to add up everything else and I'm going to stick them together and it's going to be great. And since we know that this is going to consistently reduce our list size down towards the base case of an empty list, this is actually going to work out for us in the end, as you saw when we went through the example. So let's try and apply some recursive business here. So we're going to have two cases, right? We're going to have our base case and our recursive case. Okay, so last time we used the empty list as a base case. And since here, though, we've actually said the empty list is going to be an error, right? That basically means we want our list to be at least one thing long. Okay, and that actually helps us a lot in getting our base case. Because if you think about it, what's the easiest, sort of most direct way that we can determine the minimum of a list? Like, what would be the easiest list that we could give someone and say, well, what's the smallest element in it? Okay? Now, you might try and think, oh, well, 2 is pretty small or something like that. We can actually go all the way down to 1, right? If our list is only one element long, well, what's the smallest element in the list? It's the only element in the list, right? It's, you know, default, win by default. So what's the first thing in our list? That guy, list is 0. It's the only thing in our list. So, you know, it's sort of excluding this for the moment. We basically got a, well, if they give us a list of length 1 and they want the minimum, well, I'm just going to give them back the only thing in the list, right? Makes sense. And now we try and sort of extrapolate on that to try and hit the recursive case. Now I'm going to apply that strategy I was talking about before now, right? So I've already sorted out the base case. So now I basically need to think, now let's try and assume that my function works. How can I sort of recur on how can I sort of handle a single recursion, like a single iteration of this loop that we're trying to set up recursively? So in other words, if I have a big list and I'm trying to reduce it all the way down to just a list that has only one element in it, right? Well, we can basically go, well, let's just try and get one thing out of the list each time, right? If we try and make our list one thing smaller each time by ensuring that we've removed an element that wasn't the minimum, then we're eventually going to end up with a list that only has one thing in it where it was the smallest, right? So we would set up a return, okay? And now in this case, there's sort of two options. Let's just say I look at the first element in that list every time, right? Let's just say I'm looking at listy 0. We've got two options on listy 0. Either it's the minimum or it's not, right? Pretty cut and dry, but that's sort of how you kind of have to approach recursion. It's either the minimum or it's not. So in other words, if it is the minimum, what would we want to do? We would just want to return it straight away, right? But if it's not the minimum, then we would want to keep going with our minimum algorithm, but with the rest of the list, right? Everything except that first element. So basically, we've come down and we've basically got two options here. Either listy 0 is the first guy, right? Let's just check this in a string because we're not trying to do any sort of logic here. But basically, listy 0 is either the minimum, or we want the minimum of whatever's in the rest of the list, right? So the minimum is either this guy or it's something in here. Now, what is going to give us the minimum of the rest of the list, right? What's a function that gives us the minimum of the rest of the list? Well, we're going to apply that sort of thought process I was talking about here. And we're actually going to say, well, I'm going to assume my minimum function works, you know, like magic. Let's just assume it works. Then basically these are our two options, right? Either listy 0 is the smallest or minimum of the rest of the list is the smallest, okay? And at that point, it's actually, it's pretty simple, right? Because we've got two options and we need to return the smaller of the two, okay? And Python actually has a built-in for this, and that's min, right? Which basically says, if you give me a couple of things, I'll tell you which of these is smaller. Now you might argue that I could replace this entire function and recursive business with min, and you would probably be right in any other situation except when we're doing a recursion shoot, because that's not how you learn. You learn by doing recursion. But the gist of this function, I'll just sort of show you. You know, min of 2 and 4, min of 4 and 1, right? It's just going to give me back the smaller of the two things. You could also set this up with some sort of if statement, right? Something along the lines of if listy 0 is less than the minimum of the rest of the listy, right? And then you could sort of treat that with an if and an else. Okay, but sort of to make this look a bit cleaner, I'm actually just going to use the min function here. Okay, now let's actually see how if this works. So minimum, and let's get a randomly ordered list so we don't have any sort of ascending bias or anything like that. Cool, one. Let's try one more. Oop. Oh, I forgot to put the... Oh, jeez, I muffed up my list majorly there. Cool, 0. So let's kind of reiterate what's happening here. I guess we can sort of, we've got this sort of rubbish empty situation where we get a value error, right? But who cares about that? We're here to learn about the recursion. So we've got this base case. If the list is 1, right? If there's only one thing in our list, return the thing in the list, right? That's our base case. Otherwise, we got to hit this recursive case where we're sort of going, okay, return min of what's going on here. Okay, so let's actually try and break down this list here. I'll try and sort of give a rundown of what's happening here. So we call minimum of 3, 1, 4, 6, 9. Okay, we call that. Now we're obviously not going to go into any of these cases because our list is longer than that. So we're going to hit this recursive case and it's going to say, cool, return the min of list is 0. Now the first thing in our list is this 3 and minimum listy 1, minimum, right, of the listy 1 and onwards. Okay, now what's this list 1 and onwards? Well, we cut out the 3, right? So it's just 1, 4, 6, 9. Okay, so now we've got to figure out what that one's going to call. So minimum 1, 4, 6, 9. Well, that gives us the min of, what's the first thing? 1, and minimum of this. Minimum of, we've cut out that first thing again, so we're left with 4, 6, 9. Do I have enough brackets here? Probably 3 brackets. Oof, we're going to get pretty thick on the brackets here, but okay. Call that one again. Same thing. Min of 4 and minimum of 6 and 9. Sorry if I miss a bracket. This is getting a bit hard to read. And what do we got left there? Minimum of 6 and minimum of, was only one thing left in our list now, that 9. Okay. So since there's only one thing left in our list, we have hit the base case, right? We've hit this len of listy is 1. So minimum of 9 just gives us back 9, right? Because if we're trying to get the smallest thing in a list and it's 9, then it's 9. Kind of a bit self-explanatory there. 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. And now we've hit the end of our recursive stack, right? Now Python unwinds out of the end of it all the way back up. Okay, so let's sort of, we gotta, it's sort of like maths, right? We gotta go with the deepest brackets and see this point here, and it's gonna go, okay, cool. What is the minimum of 6 and 9? Well, Python knows what that is, and it goes, oh cool, it's 6. Okay, then it goes, what's the minimum of 4 and 6? That's 4. And it goes, what's the minimum of 1 and 4? Well, that's 1. Then it goes, what's the minimum of 3 and 1? And it's 1. Okay? Well, that glass shatter in your head, right? But let's sort of take a step back and think about how we got here. We've had this base case of 1. And we go, if there's only one thing, then we're done, right? But the sort of the trippy part here is this recursive case, right? The assumption that if our function works, we can sort of apply it already as long as we're reducing down to our base case. So basically going, well, give me the smaller of the two things. Either the first guy is the minimum or the minimum of the rest of the list is the minimum, right? So there's only two options. And at that point, it becomes sort of really simple conceptually if you can assume that this minimum function will work. Now, in this case, we can assume it'll work because we're always reducing our listy down one at a time, which means we're inevitably going to end up at the base case of 1. okay? There's no other way. Since we start with something that's not empty, we're always going to be able to reduce back down to 1. Okay, and then in that case, we sort of just get this expanding of all the minimum functions, and then we unwind backwards and end up back with all these min functions sort of nested inside each other as we keep going deeper into the recursion. Okay, now I understand that's pretty hard to get your head around. Sort of just have a look at this. You can sort of see the stack trace, if you will, of all the recursive calls. So if you need to have a bit of a look at this, pause the video, sort of try and take it in, try and implement something yourself. We could do a max in much the same way, right? Either by using max here or by doing like an if check. And honestly, this one is quite similar to the add, right? We sort of just reduced our sample space one at a time until we hit the end. Okay. I'm actually going to call that for part 1. So as always, you've got any questions at all, and I understand this is a very trippy concept. It won't be too much on the exam, but there will definitely be some recursive aspects on the exam. So really want to try and wrap your head around it. And yeah, like I was saying, if you need to drop any questions on Piazza or in the comments section, just go ahead. And otherwise, I will hopefully catch you guys in part 2.